people are writing more issues they're writing issues, which are problems in the code, at a higher velocity than they're writing lines of code. That's not good. That's not good. And I was thinking about doing this not just for YouTube and Kick and stuff, but to drop some of this stuff on LinkedIn. As I think some of you have seen, we're starting to get quite a bit of a following on LinkedIn as well. That's kind of GTT's growing organically to a bunch of different places. And we're gonna change Mentor so it should be free for everybody. Just want to make sure everybody can see this. And so not just open source, but anybody, that you can download it and use it on any repo. But it's going to stop you at certain screens. So it's basically the Nautica model. It'll be freemium. But part of the thought process is we would talk about repos that matter and repos that are I'm trying to think of how to say this. I don't want to say like a public flogging so much as raising awareness about some of the issues to help add visibility and maybe get people to contribute to making some of these repos better, and also to spotlight the repos that are really good, right? So OpenSSL, this does scare me a little bit. I didn't even know, I don't know if you guys know, but there's this other SSL repo that Google's been using. This one, this BoringSSL. And the reason why I know about this is I was talking about how sort of dissatisfied I am with OpenSSL, and someone mentioned, oh, well, you know, like a lot of people are switching to the BoringSSL that Google created, partially because of the reasons that you're talking about. And so, as you can see, like the number of points here is not great. There should be more points for this, but the score you can see is already better. That here, we'll just do this side-by-side comparison. So you can see OpenSSL is, yeah. Lifetime is better for OpenSSL, but I think that that's a forking thing. I think that's related to, I think, keep in mind, I'm a total noob here. I don't know about BoringSSL yet, so take everything I'm going to say with a grain of salt. Did it do like just a partial inference? Looks like they did. But it looks like maybe BoringSSL started in 2014. And I don't know if it was a fork or what. Let's see what Google has to say for this. A divorce born of necessity. All right, this is what I thought, is that it's a fork. Evolved in a fundamentally different animal, one optimized specific owner rather than the general public. Okay, that's not super great-ish. Because I'm curious about the generalization. Okay, so BoringSSL, it's for internal Google projects. No stability guarantees. It's stripped. Wheesh. Okay. Yeah, we've got some work to do here. Anyway, what the plan was is that we would start talking about some of these things. Let's see if I hit refresh, if this is gonna resize these. Okay, cool. And I haven't actually figured out exactly how we would go about this. Part of me is I was thinking that maybe it'd be driven by the public, is people would say, hey, do a VOD on Falcor DB, and then we do that, or do one on Hypershift, and then we'd do that. But then I also think that maybe we'd talk about ones that are look at this. Look at this one. This is VS Code, guys. This is Visual Studio Code. This is Microsoft, right? This is a $1 trillion company. Why is this code so bad? This... Oh, yeah, we have some new UI stuff, by the way. Yeah, check this out. Like, the UI's getting better. Let's look at this control expression. Like, oh. Just because you can do something does not mean you should do something. This is, first of all, whenever you do ternaries inside of control expressions, whether it's a while or an if, this annoys me significantly, because, like, my view is, yeah, boy, I tell you. I actually, just so you know, Maximus, I've seen this. I've seen it where some of the open source that's out there, it appears, I'm going to foster goodwill. But it appears to be written as if it's bad on purpose, so people will not understand it. I'm not going to mention any names, but there is a specific open source project that I was looking at that I know the people involved, and they are like super geniuses. These people can like write code in their sleep. They are world-class experts. It takes them almost no effort to write world-class code. And this code was abysmal, which led me to basically one of two outcomes. One, they just didn't care, and so it was bad code because they just don't care. But that code was too important to essentially not care about. Which then leads me to the other possibility, which is it's intentional. And I don't even like to think those thoughts, because I'm all about fostering goodwill. But when you know someone, it's sort of like, I think many of you know that I've spent a lot of time coding. And so if I were to write code like this, I think some of you would probably be like, Goju, why you tell us not to do this? Why would you embed ternary inside of an if expression? Because it's basically an embedded, it's like an if inside of an if, which complicates the logic significantly. And when you have the potential for short-circuited logic that acts differently based on operator precedence order, ooh, like in this case, it's not that bad because these ands are basically all at the same level. So there's not an or that would change the operator precedence order. And because they're all ands, you essentially need all of this to be true. The challenge or the difficult part is if you have a non-senior programmer come in, they may edit this in line and add an additional condition and add like an or to it. Because what's the alternative? You have to like yank this out. But the junior programmers tend to be scared to massage code like this because you see this code and you're like, whoa, it's complicated. I don't want to mess with it. It works. So just like add the tiny little thing and then make it keep working. So then you get more and more spaghetti code. You get more and more like badness. And then it starts doing these really unpredictable things. By the way, just as a funny aside, I gotta I don't know if I should say this. When I first started learning about JavaScript and TypeScript, I didn't know what this operator was. I didn't know what 3 equals meant, and I had to get help. And now I understand what the triple equals is. Basically, if I understand it correctly, and JavaScript, TypeScript people, please chime in if I've gotten this wrong, is that it's performing an equality check, which is what the double equals is, but then it's also doing this additional comparison to make sure the types are the same. So it's basically saying that not only do these things does node.item handle have to equal the value of current node.parent.item.handle, these also need to be the same types. And so that's what, as I understand what's going on here. All right. Easy enough, right? But now ask yourself this deeper question. Is this the right way to do this? Like, why is there not a triple equals in most of the other languages that exist prior to JavaScript and TypeScript? Like, why does C, C++, Java, C#, Go? I don't know if Go has this. Why do those languages not have the triple equals? Well, the reason why is they don't do implicit type conversion. That's why. That if you have type mismatches, that the systems will throw their hands up in the air and say, no, these types are incompatible. Now the next question is, do you want implicit type conversion? If you're writing prototype code, I think you want it because it just is going to do stuff faster. But if you're writing production quality code, I think oftentimes the last thing that you want is implicit type conversion. And the reason why is that you don't know when these silent typecasting things are happening. And that's why the triple equals operation doesn't exist in these other production quality languages, because that would be nonsensical. You would not want, okay, maybe I gotta like cool my jets here. I can feel the Professor Goju coming out here. Okay, deep breaths. There is a lot of danger for things to happen implicitly in a language. And while those implicit behaviors can be helpful when you're doing rapid prototyping or you're writing smaller programs that are not necessarily going to be the next operating system, it can make sense. But when you're getting into more advanced systems like video games or operating systems or browsers or stuff that like is going to need to have far more deterministic behavior where things are clear, right? It's the clarity. It's the upside of being able to see and understand exactly what's going on without having to magically like know about all the hidden mumbo jumbo things that exist in the system. And that's why doing implicit type conversion is generally not a good thing. It should be the other way. It should be, this is my strong conviction, that if you want type conversion, you should explicitly say, I want type conversion. So what you want to do is not support a triple equals, make double equals, only do equivalents when it's the same type. And when you have type mismatches, say you can't do this type of conversion unless you cast to the other type. Now, why is this super beneficial? Because then the next poor person that's coming in and going to have to code, they know exactly what the hell is going on. Whereas if you do it this way, now what you get is all this code in JavaScript and TypeScript that's triple equals. And then everybody's wondering, like, why the hell do we even have double equals if nobody uses it? Well, the reason why you have it is the language does. The language may not have been designed in a correct way from the get-go. And because they were striving on just making things as easy as possible, they made a really critical design decision flaw in the language that now is being short-circuited by an additional feature that's added to the language to band-aid broken behavior in prior versions of the language. That's crazy. That's like, that is the definition of like insanity to me. It's like you are trying to put band-aid solutions on symptoms that are side effects of bad design rather than trying to fix the actual root cause. It's like if you went to the doctor and you because you broke your arm, and they basically are just like giving you a whole bunch of painkillers rather than trying to fix your arm, right? Just keep taking these painkillers and you'll be okay. How does that fix the broken arm, doc? Oh, well, it doesn't, but don't worry. You just keep taking the painkillers and you don't need to ever fix the broken arm. That's what this is to me. This is a painkiller trying to circumvent a language design flaw. Now, let me get off my high horse and say I'm not an expert in JavaScript or TypeScript. I do teach programming languages at the graduate level and have done that for some time. So I understand languages, I think, like kind of well. And I understand the need for this, but the need for this is because I think this was so not well designed. Maybe that's the nicest way I can say it. I'm super tempted to use stronger language here, but I'm trying to be super nice because I'm not trying to like bash. Just to be clear, I'm not trying to bash on the JavaScript and TypeScript programmers of the world. That's not my goal. What I'm trying to get at is it's so frustrating when I see really bad like language design and then additional language features added because of poor language design as a fix to try to cover up a mistake. And I get it, right? I like maybe I'm being too idealistic. I just think like I think if they would have slowed, and maybe the message here is the message for the future is I feel like for language designers, you do have a huge responsibility on your hands. And keep in mind, like I've worked, as I think many of you know, or some of you know, I've worked directly with the standards committee for C and C++. And some of the stuff that we worked on is to actually extend standard C and C++ with transactional memory and potentially other things. So I'm not just kind of randomly talking here. This is something that I deeply care about and spend a lot of time thinking about. This matters a lot to me. And it's shocking to me because it's like it's sort of like, I think in some sense, and maybe this is a really good analogy. I feel like the imperial system that the United States uses is bogus. I think that for all intents and purposes, the metric system is just definitively better. But our founding fathers in the United States made some bad decisions. And now they keep patching the bad decisions because they didn't think like deeply enough about the ramifications of how these core systems would affect the future. And like the metric system it's beautiful for a variety of reasons. A lot of it has to do with the elegance that it has for growth, the sort of natural way that it modifies itself for scale. This is why we use things like for example, in all of our computing systems. Yeah, exactly. Right. That's what Colin just said. Like, this is why even when you talk about computer systems, we talk about things like kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes. You know, it's like, what is that? These are all 3 orders of magnitude shift to scale. That's exactly what's happening every single time. And that's what the change in the prefix of those words means. The change from kilo to mega, and mega to giga, and so on and so forth, giga to tera. And that's so beautiful because every time it levels up, everybody just knows. You just know implicitly what the system is because the rules don't change. But then when you have the imperial system and you have something like 12 inches is a foot, and then like, yeah, it's just, it's really hard to understand. It's really hard to teach. It's really hard to extend. You've got things like miles that like 5,280 feet. Who decided that? And then the problem is the problem is its foundation. It's the foundation that is wrong. So no matter what you do on top of it, it's sort of like you're screwed a little bit. You're like, it's very hard to fix this stuff unless you can change the foundations. This is why I'm like 1000%, I will not bend on deterministic AI. Like I've been doing AI long enough that anyone that tries to argue that stochastic AI can be the foundation of any real system, I think is either they're selling you something or I think that they're very confused. And I think, unfortunately, there's a lot of smart people right now that they know better, but they're selling it because it's good for business, but it's not good for science. It's terrible for science, like as a lot of people are finding out. And then they're trying to build systems that rely on stochastic AI. And they're like, wait a second, how do you run these unit tests? Like the results keep changing. Like people are saying it's prompt engineering, but I type the prompt and then I get an answer and then it's the same prompt and I get a different answer. Like, how is that going to work as a reliable system? Yeah, here's the clue. It won't. It never will work as a reliable system. It can't because it's stochastic. So you cannot use that as the foundation of the castle or the foundation of the pyramid. You cannot do it. You need deterministic science. You need deterministic mathematics. You need determinism for advances in science. It is literally written into the scientific method. The scientific method basically says you have a hypothesis and you test it and then you keep testing it. And the moment you get deviation in those tests, you either patch the algorithm or you patch the system to fix it, or you throw it away. That's how important determinism is in science, right? And the scientific method is the foundation for all scientific advances that we've had for the human race for thousands of years. So why suddenly would those rules change? Because we have an AI system and people think it's super intelligent, which it's not. Like a very clear way to tell if something is like super intelligent, at least in my book, is that not only does it have to be faster. By the way, I'm really soapboxing here, right? Everybody can blame untranslatable metaphor. He does this on purpose because he knows as soon as I start talking about science, my chill attitude of whatever is gonna like go away, and I'm gonna get hard line and really lean into this stuff. But one way that you can tell something is not a superintelligence is that it has certainty on something, and then it can be easily convinced to not have certainty on that thing. That's not superintelligence. That's super dumb, right? Like all the super intelligent people that I know, if they have unwavering conviction about something, like my unwavering conviction about determinism in AI, that's not going to change based on someone just like yelling at me and like, or threatening my life saying, you have to change your mind, Goju, or we're going to slice your throat. Just slice it. Slice it. I guess my my days are over. I'm not going to give in. I'm not going to change my ethics or my value system because you're talking more loudly, right? Yeah, yeah, exactly, right? Yeah, let's invoke Feynman. It doesn't matter if your experimental results deviate from this, then it just is not correct. So so the same reason why stochastic AIs can never be the foundation for the advancement of science. Strong claim, like 100% strong claim. It cannot be the foundation. It can be used as tertiary things. It can be used to help you brainstorm, used for creative ideation, used for rapid prototyping, used for all kinds of cool, fun things that you kind of are fiddling with. But it can't be the base logic system for the spacecraft you're building or the operating system, because that thing needs to work deterministically. So the same is true here with this thingamabob. This is a hack. This is a band-aid for something that was clearly not well thought out, at least in my mind, on why this is wrong. Is that they wanted to somehow make the language easier to use. I'm speculating here, but like I work with a lot of these language designers. This is why they did it, because this 3 equal sign, I don't know if this originally even existed. It's just like, oh, equality. It'll just have the 2 equals and it'll do the automatic type conversion. It'll be super easy and everything's going to be great. And then you see throughout all this code is that you'll see these triple equals, or you'll see the not and then the double, right? Why do you see this overwhelmingly? Because people realized it's super bogus to do this. This is not the way to do it. So the developers have realized, oh, shoot, it shouldn't do this. You don't want that implicit behavior. Instead, you want it to be explicit. And if it doesn't match, you should get some sort of runtime error or a compiler time error. So the developers have basically told us through their own experimentation and usage that this is not right. And that's why you see this throughout the code rather than just the double equals. Whereas if you look at all these other languages, like production quality, C, C++, Java, Go, C#, so on and so forth, what you'll see is the double equals, and then sometimes you'll see a cast. And the cast is basically doing what the double equals is. So this is, you know, I could be wrong. Like, again, I'm not an expert in JavaScript and TypeScript. I want to throw this out there that I might be wrong. I'm not an expert in these languages, but after I started to understand what this is doing, then, and this is like one of the things that I do, and I encourage all of you young scientists and programmers to do the same. Once you understand how something works and what something means syntactically, then probe a little bit further and ask yourself, okay, so then why do other languages not have this triple equals? Why is that? And then you'll get to that answer, and then you'll understand why, and then you have to ask yourself that next critical question is, now that you understand the reasons why these other languages don't have it, which one is right and which one is wrong? Now, it could be they're both right. It could be. But it could also be that Like, for example, if JavaScript and TypeScript never saw the light of day for production quality systems, I would say double equals doing automatic type conversion could be the right thing to do. Could be. But what are we looking at here? We're looking at VS Code. This is part of the main line of Visual Studio Code. So this is everywhere in production systems. So this is at production now, right? That's why we're looking at it in Mentor. And so now it's no longer a prototype. And now it's fundamentally something that is a different beast, which raises the question of, is this designed the right way? Yeah. Anyway, the higher order bit is we may start talking about a repo a week now that we're basically through our Series A funding for Merly, which is part of the reason why I was doing fewer VODs, fewer streams, and all this stuff, because I was busy doing like VC stuff and keeping the company alive. But that's kind of my high-level plan, just so you know, untranslatable. And if you have other ideas, let me know. We're also, I'm really interested in, there are two things that I am deeply going to focus on for 2026. Well, actually, it's like a few different things. Okay, so the first thing is my role at the university is evolving, which is partially inspired by me and partially inspired by them. And I think that's good. So that's one thing you should kind of be aware of. That's not going to take time away from GTT. If anything, I'm going to use GTT as a segue for the university. I'll just have some of my university students, like, it'll be required reading or required watching for like GTT episodes, not the other way around. But I'll probably be doing more research at the university in the coming years, getting kind of back to my core. The second thing is in terms of research advances, one, I'm gonna write the white paper and do the VOD series on this new type of machine learning method that we've invented that I think I've shared is called DIF, D-I-F. It's this. It's this. Yeah. That's maybe the second thing. The third thing is we really want to expand the coverage of Mentor so it does more than just control expressions. And that, I think, is really important because it'll get into the heart of what... Actually, let's go back. What Untranslatable was talking about. Because I want to reason, I don't want to just talk about this one expression. I want to talk about at least this whole method. And probably more. Yeah. I don't love a lot of deep nesting, as I think you guys know. At some point, I want to talk about concepts of iteration and whether or not iteration has any business in programming languages. Yeah. I think no matter what, control expressions, at least in terms of if expressions, will always, I think that those will be present. Like, okay, let's take a step back. from my perspective, almost all programming languages are based off of formal logic. First order, third order, all this stuff, like predicate calculus. And if you look at the semantic capabilities of those logics, you'll see a direct overlap in programming languages in terms of what they can express. For example, if you have like formal logic, it will have if statements, and it'll say if A is true and B is false, all that stuff, right? So if expressions will be there. And then you'll also see this thing where it's like the upside down A, like for every X, there exists some whatever. Okay, so that's this, basically, in programming language. The upside down A is this for. It's just that this is across all the, essentially it's iterating over this container. This is the way I think about it. And that you have this, the way to express this in like first order logic would be for all X, there exists some X that does this. So here's the for all X, and then here's the check on there exists. There exists some X that does this. That's what you have with these two things. And then it goes further, right? Now, the question that I think we get into when we start to dive deeper, like assuming you're cool with that, one of the questions I have is, are there better ways to express these things that remove the complexities of loops from like the syntax of the language? So semantically speaking, you still have the ability to do stuff like look over an entire range, but the way you express it changes because you want these operations to be a little less divisible, like ranges. And it's not exactly, I mean, one could argue this is a range iteration, right? Like you're like, this is actually walking a range, Goji. What are you talking about? Well, it is, but see, you can still break out of this for loop, right? So at any point, you can just kind of like exit this, and then somehow you have sidestepped this logic. And then on top of that, you can add things inside of this that start to wholly complicate this. Like maybe this is getting into a discussion of the differences between functional languages and like object-oriented and procedural languages. And yeah, so are you asking, do we support recursion? Because recursion is like a form of iteration? Or are you saying like, oh, do we supply recursion as like a replacement for this looping mechanism? But whatever it is, yeah, your intuitions, I think, are right, is that it's teasing out ideas that I think we have taken for granted and assumed they are principal to languages, but maybe not. Maybe not. Like, think about go-tos. There was a time when go-tos were commonly used. And then we kind of leveled up and realized, yeah, do we really want to use these go-to things? They kind of get us into trouble, and they just allow too much bizarre behavior, right? I think this is the fundamental reason why we kind of got rid of go-tos, is that you could just do some second. I'm not sure I know what you're asking about for. Can you give me some more words? But so what I'm trying to understand is, and this is half-baked, right? Like this is, I don't have this like fully grokked, but let's just say I've seen certain DSLs, domain-specific languages, that have elided away the need for iteration and still had the potential to be like a Turing complete language. And the way that you program in these languages, it becomes fundamentally different. Now, the real question, I think, is, and these DSLs can be super powerful. They don't necessarily generalize, by the way. This is one of the major trade-offs, is they don't generalize. So what does that mean? It's like you can't, like C and C++, they kind of generalize. You can use them for whatever you want. So these DSLs don't necessarily supply that, but maybe that's what we want. Like, for example, maybe we have these system languages that do all the stuff for us. And then we have these DSLs that are constrained, but they become super powerful because the constraints get us away from dealing with all the crazy problems that come about from this type of heavy nesting. Right? Like, I don't love this. Why do I not love this? This takes too much mental effort for me to understand what's going on. I have to keep all these things in my cache, right? I have to say, okay, first we're in a function. Okay. Then we're inside of this loop. Okay. Now we're in this loop, and now if this is true, I'm going to go into another scope further. All right, now keep that in your head, Goju. We're in a loop, and now this if statement is satisfied. All right, so now we're doing something. We're going to create this variable if we can, otherwise we don't. All right, and now we're going to loop again if this variable exists. All right, so hold on. We're in a loop, we're in an if, now we're in another loop. Oh my gosh, my head, we haven't even gotten to the point where we're doing anything. You see what I'm saying? Like, it's not until we get to this point that we're actually, I think, doing the thing that it is we're trying to do, which is set the current node for this whatever thing. So then we can decide if we're going to add it into this element. It literally is not. And by the way, I just figured this out as we're looking at this code. I haven't looked at this code before. You can tell because it's only been viewed one time, the time right now. So I'm literally figuring this out in real time, and that's too hard. It shouldn't be that hard. It should be easier. It should be that a new programmer should be able to be like, oh, you do a search on whatever this thing is to get current node, and if current node is real, then it's gonna update this list. That's cool. That's what I'm talking about. And the reason why this matters so much is, from my perspective, the goal of software, writing software, it's not writing a piece of software that works. This is super easy. Like, I think any Joe Schmo can do this. And I'm probably being a little too lax here, is I realize for people that are new at programming, it's probably much harder than that. But for all the veteran programmers that are part of the GT community, yeah, you guys know what I'm talking about. Like, you can code this stuff in your sleep. It's not hard. What's hard is writing code that is so easy to maintain that it takes only seconds to understand the context of what you're working on and then extend the behavior to do something new. Because this is, in my mind, the beauty of software. The beauty of software is not that you are building a solution. You can do this in all these other areas. The beauty of software is that you can do iterative refinement extremely fast, in seconds, because it's virtual, right? You change a line of code, you hit build or you hit deploy, and it's done. Try to do that in any other field, like in any physical field, like you're building a ladder. and you want to add an additional step to the ladder. You think you can just like add a line? And no. So if the benefit in software is, one of the biggest benefits is its speed of iterative refinement, shouldn't iterative refinement be the primary concern? Shouldn't that be like the primary directive for almost all software programs? I think it should. And that's why in this paper, oh gosh, please, Adobe. And look, see these 3 pillars? This pillar, this adaptation pillar, iterative refinement. Iterative refinement is so important. It's like one of the 3 pillars. It's wildly important in my mind. And this is what I think is somehow getting lost when we're doing all this spaghetti code. I think that it's taking something that has tremendous value as a first-class citizen, and it's like devolving it to be a 3rd or 4th class citizen because people are not doing what's necessary to preserve it. And by creating more restricted programming languages, what it does is it saves people from themselves. It basically like keeps them, this is going to sound like way too big brother, and I don't mean it like this, but it kind of like keeps them in the sandbox. Basically says, look, if you really need to go outside of the sandbox, go outside of the sandbox. But you're still learning, and so the fact that you're trying to go outside of the sandbox, we're going to save you from yourself here. Stay in the sandbox. And then if you really, really need to do it, okay, fine. But we're not going to like give you all that power right out of the gate, because you're going to misuse it. And then you're going to get yourself into trouble. And we want to create software that's super maintainable. This is part of the reason, like I'm really soapboxing here, but this is part of the reason why I think vibe coding has like devolved so quickly, is that the vibe coding systems are largely trained on a massive amount of open source, right? And this is the kind of open source that, I mean, Mentor doesn't train on this kind of stuff. Like we have a semi-trust system that filters out like bad code, but a lot of people don't understand machine learning as, you know, as deeply as we do. And so they're just training on all the data in the world. And some of that data includes things like this. And then you end up training, you know, garbage in, garbage out. And now the vibe coding systems are spewing out this really bad stuff. And everybody's like, well, the vibe coding system is saying, yeah, okay. I'm done soapboxing. At least, yeah, Colin, a code review is definitely in order. And we're talking not just a code review, brother. We're talking like a full repository review. And again, who is this repository from? That's the big question you should ask yourself. Are these people that supposedly don't know anything about software? Or is this a $1 trillion company that supposedly is some of the best software developers in the world? And if they are that really seasoned, they are really that good, how is their code this by the way, this red line, you don't ever want this red line to ever be above this blue line. This basically means that the issues in the code is now proportionally overtaken the lines of code. People are writing more issues they're writing issues, which are problems in the code, at a higher velocity than they're writing lines of code. That's not good. That's not good. That is not good. That is bad. Bad Microsoft. Bad. Stop that. And we know you are smart enough to write good code. We know. Right? At least we think we know. And do us a solid, prove us right. Because if you guys can't get this right, how is anybody else supposed to get this right? You're supposed to be, this would be like having a bank, and the bank is like losing your money. And then you go into the bank and say, listen, Wells Fargo, you guys do money things, okay? You're not supposed to lose money. You're supposed to know where the money is at all times. And if you can't figure out where the money is at all times, how can any of the rest of us possibly figure out where the money is? That's your thing, right? It's the same thing here. Microsoft, if you can't write good code, how is anybody else supposed to do a better job? Okay.